This week we're talking about two things that are really related to each other greatly: pressure in the atmosphere and winds. So we'll start with pressure because that's kind of the fundamental thing. So you got to understand what pressure really means. Pressure is combined like molecular motion of the air molecules. So think about it, the air molecules moving in random directions at all times. So the quicker they're moving around, the higher the pressure might be, the more force you're going to get in all directions. So temperature gets hotter, you would think, oh, pressure might go up. And it would if that was all things were equal. But not all things are always equal. But there's also gravity pulling the air down towards the earth, which is helping to maintain that pressure. You know, you have a whole atmosphere above you right now, that all those molecules how are they staying there? We've learned something about pressure gradients all along, that the atmosphere doesn't like to have a pressure gradient, which is basically just a change in pressure from one location to another. It would love everything to be uniform. And that location can be vertical, it can be horizontal. So you think about in the vertical, if you take your plane off, air pressure is decreasing fairly quickly up as you're climbing in altitude. So there must be one heck of a pressure gradient between the surface and the higher up you go. So what's holding that in place? What holds that in place is gravity. Gravity is the reason we don't lose our atmosphere. So there's something called the hydrostatic equilibrium. Basically, the pressure gradient force must be equivalent coming to the gravity. So the two equal each other out. If they don't, and they sometimes aren't completely equal, but if they don't, then we'll begin to lose atmosphere probably. And that would not be a good thing for all of us here on Earth. So that's just the basics of pressure right now a little bit. And with that being said, there are a whole bunches of ways of measuring it. And I'm sure each one of you has different preferences you use on your plane. But let's just deal with, there's a station pressure and a sea level pressure. All right, it can be very, very different. If you're flying into Boulder, Colorado, their station pressure is going to be a whole lot lower than the actual sea level pressure at that location, because their elevation is up about a mile high, whereas sea level is about a mile down from that or whatever. And that's a significant, think about it, in a normal atmosphere, that's a significant pressure gradient that usually exists. So there's what the meteorologist is interested in is sea level pressure. We want all the pressures to be on a uniform surface. And we've chosen sea level to be that uniform surface. So if you look at a weather map, all the pressures on that weather map have been reduced by a method to be sea level pressure. So let's just take a quick look at one weather map. And we'll go to right here, surface weather map. All these pressures that you see analyzed, and here's your isobars in the solid line, all of them are sea level pressures. So we're not getting huge low pressure out in the mountains and the Rockies and stuff caused by elevation, because we've reduced everything down to sea level. So just wanted to show you on the weather map just what that looks like. You know, all these pressures you see here are all in sea level pressure. So with that in mind, we can see it basically on sea level pressure on here is just, there's very nice big high pressure out over the western US here, low pressure over Nebraska, and there's low pressure up over north of New England as well. So, and a high over the mid-Atlantic coming in off the Atlantic. So there's your pressure field. So you can see the mountains do distort some of our approximation to bring the pressure down to sea level, and that's probably why some of these circles are a little different out here in the mountains in the Northwest. But this is a general picture of what the pattern looked like at that time. If you looked upstairs at an upper level chart, basically these are contours. These contours represent the height each height where it is actually 850 millibars. So if you were to go from Nebraska and go due west, you would see that the 850 millibar surface is slowly rising higher and higher until you get out into Colorado. By the same token, it would be doing the same thing further east you went, getting higher and higher. Now, just notice one quickly, and we'll get into reasoning later. Low pressure, Missouri-Nebraska border. Low pressure, Kansas, Oklahoma. So you can see there's actually even a gradient aloft on pressure as well. So with all that being said, all these pressure changes and stuff can affect your pressure altimeter in your plane. And I found a pretty good, the book has a really good reference on this, so I just thought I'd use theirs. So here's you're flying higher than you think you are if the atmospheric pressure is greater, 30.5 millibars here in this case, actually inches of mercury, than it is on a standard atmosphere. So if one of the things you would know is if your pressure is, you're flying into a high pressure area, for example, you're probably flying at a higher altitude. If you don't make adjustments to your altimeter, then you would expect to be. The same would hold in a low pressure system. If the low pressure, you're flying into a low pressure area, you're going to be flying lower. That's just one piece of the puzzle, though. Of course, nothing can be totally simple in meteorology like that. Here's another thing. Temperatures play a role. If the air is very warm, think about it. The molecules are flying all over the place, and they're tending to be a little bit further apart because of that motion, that increased motion and warmth. We talked about temperatures and the motion of molecules that way before. So think about it here. They're further apart. There's going to be a little less density. So if you're flying in a warmer thing, the altitude is going to change slower in the vertical. So you actually are flying a little bit higher. When you get to the standard atmosphere, you're right on it. When you get colder than the standard atmosphere, you're going to be below it again. That not as drastically, maybe, as if the pressure changed dramatically from one location to another. But these are all features that you're going to be dealing with as a pilot, and you probably already have dealt with it, learning it. So it's just something to think about here and learn from. So let's go with that in mind. Let's go look at METARs for a little bit here. I'm getting my METARs through the Aviation Weather Center. You can get yours wherever you want. There's thousands of sources of METARs. But, so let's just take a look at, I don't see Houston here, but here's Dallas-Fort Worth. Let's look at Dallas-Fort Worth METAR. You'll see an A near the end of a METAR. That's the altimeter setting. That means that is pressure in inches of mercury, in this case 29.94 inches of mercury, and that is reduced to sea level at that location, and it's reduced using a standard atmosphere. So if the atmosphere is normal, if you're in this time of year, you're probably not. It's probably going to be a little warmer or whatever, which could affect that that altimeter setting actually means to you. Here's another pressure, sea level pressure. Now this one takes into account the actual temperature change in the current conditions, does a calculation on that using the actual temperatures to adjust the actual station pressure to sea level. And this is in millibars, 1012.9 millibars. I'm used to dealing in millibars, I admit it. Well, you all probably are very familiar with inches of mercury. But they're relatable to each other. But this would be more accurate as far as the sea level pressure. This one probably not off by much, but it might be off a little bit. So we tend to analyze sea level pressures when we're analyzing weather maps. And that's why you see it here. So the sea level pressure, you notice it's 129. Well, if this is above 500, the odds are that you're going to put a 9 in front of it. So it might be 951.2 would be the sea level pressure. For example, if it was 512 here instead of 12.9. Now this one I added a 10 in front of. If the number is below 500, typically it's going to be putting in a 10 in front of it to make the millibars work. So this is what you're going to be doing this week in part of your lab, is learning how to read sea level pressures, altimeter settings as part of that. And so we'll stop there for this one, and then we're going to continue in wind here in a minute.